Welcome to datascience.show, the podcast where data science meets executive leadership. We talk with top AI and analytics thought leaders about turning data into real business impact. If you're a C-level leader or data expert shaping the future, you're in the right place.
I'm your host, Mirko Peters. We explore how data science and AI drive real business impact, straight from the leaders making it happen. Today, Economics First ML, a practical C-suite playbook to make models protect margin, not erode it. Here's the hook. You can ship a model with world-class accuracy, celebrate the lift in F1 or AUC, and still wake up to a surprise drop in margin next quarter. Why? Because accuracy is a proxy. Business outcomes are dollars and losses, and those are often asymmetric and conditional. In this episode, I'll walk you through a concrete, executable playbook, how to translate strategy into objective functions, dollarize model outcomes, design sampling and loss functions that reflect revenue and risk, run a defendable 90-day pilot, and operationalize economic SLOs and governance so finance and data science speak the same language. Quick context. Imagine the leader responsible for a multi-billion-dollar revenue stream, running thousands of daily decisions, pricing offers, fraud flags, retention treatments. That leader does not care about AUC. They care about margin and predictable cash flow. They need models that are cost-aware instruments integrated into P&L conversations. The scope I'm addressing is enterprise scale, cross-functional programs with product, finance, legal, and data engineering involved. Typical stakeholders include the CFO, who wants reconcilable P&L numbers, the CDO, who owns data and modeling, and ops owners who enforce execution. The economic exposure can be direct, lost revenue from bad pricing, or indirect, increased false positives that damage customer lifetime value. So let's move from why to how. Step 1. Define economics first objectives. Replace accuracy first goals with dollarized objectives. Ask 2 questions for every model. What is the marginal dollar impact of a false positive and a false negative? And how often will each occur under the proposed policy? If you can't answer those, pause the launch. Translating KPIs into loss functions is straightforward in principle and nuanced in practice. For a fraud model, a false negative is direct loss, money stolen or chargebacks, while a false positive is friction, blocked legitimate transactions, customer churn, and operational review costs. Dollarize both sides. Build a loss function that weights errors by their expected dollar outcome, not just their frequency. Sampling matters. If your training set oversamples rare fraud events without reweighting to reflect expected encounter rates and dollar impact, you'll optimize for edge cases that don't move the P&L. Use stratified sampling that matches production distribution or simulate production exposure and train on dollarized outcomes from those simulations. Example 1. Fraud scoring. We ran a dollarized backtest where each prediction was reconciled to actual chargeback costs and recovery rates. By replacing an accuracy-weighted objective with a dollar-weighted one, we reduced false positives by 40% at the same net loss rate, meaning fewer legitimate transactions blocked and higher net revenue. The key was shifting the optimization surface to reflect real costs. Example 2. Dynamic pricing. Standard practice tunes models to maximize predicted conversion, or CLTV proxies. Instead, embed margin per transaction into the objective. When price elasticity varies across segments, a price that maximizes conversion can still reduce overall margin. The fix? Let the model predict both demand response and contribution margin, then optimize on expected margin, not just volume. Example 3. Churn interventions. If an outbound retention offer costs $50 and increases retention probability by a few percent, you must compare the incremental lifetime value against the cost of the offer and any cross-sell opportunity lost. Build policy functions that recommend offers only when expected CLTV uplift exceeds cost, plus a margin for uncertainty. How do you validate? Start with simulation first and dollarized backtesting. Create a replay environment that replays historical decisions, injects alternative model outputs, and estimates realized P&L under counterfactual policies. Then run a controlled experiment, A/B, or better, a champion challenger or causal attribution test tied directly to P&L lines.
Design experiments so finance can reconcile results. That means tagging impacted transactions, logging decision context, and automating reconciliation scripts that map model decisions to ledger outcomes. The transparency here is non-negotiable. If finance can't reproduce the economic story, the model won't survive budget review.
Let's talk trade-offs. Complexity versus clarity is the most common executive tension. A complex economic model that simulates user behavior, supply elasticity, and cross-channel effects might be theoretically optimal, but it's slower to maintain, harder to audit, and more brittle. In many cases, a simpler cost-adjusted threshold or two-stage model gives you most of the value with far lower governance costs.
Interpretability matters. When dollar impact is on the line, decision owners demand explanations. Use interpretable models or model-agnostic explanations tied to economic outcomes. For example, show why a decision increased expected margin or decreased expected loss in business terms, not statistical jargon.
Data requirements and latency are another trade-off. Real-time price decisions may require sub-second responses and simpler models. Batch scoring for portfolio-level hedges can use richer features. Map model complexity to the decision latency and economic value. High-frequency, low-margin decisions need high-speed, simple models. High-value, low-frequency decisions can tolerate complexity.
Operationalizing economic SLOs, every production model must have at least 3 finance-aligned KPIs: dollarized lift, expected downside risk, and reconciliation delta. Define SLOs for each. For example, minimum expected incremental margin per 10K decisions, and a maximum allowable reconciliation gap versus finance. Automate alerts when SLOs drift, and require an owner sign-off for any degradation.
Governance and decision rights. Put economic assumptions under audit. A simple governance pattern is to require a short economic model spec for every project. Inputs, assumptions, sensitivity analysis, and who owns the P&L reconciliation. Assign decision rights. Product owns the policy. Finance owns reconciliation and risk tolerance. Data science owns model behavior and testing.
Incentives matter. Don't pay teams on model metrics alone. Tie part of compensation or budget to measured economic outcomes over a meaningful horizon, 90 to 180 days, and protect teams from noise by smoothing performance signals. This aligns behavior toward long-term margin contribution, not short-term metric wins.
Boards want dashboards. Provide a concise, auditable KPI set, dollarized lift, variance to forecast, reconciliation delta, model confidence intervals, and a brief narrative on key assumptions and mitigations. Keep it readable. 1-page summary, 1 appendix with methods, and 1 appendix with reconciliation scripts. Now, the 90-day pilot blueprint. Week 1. Align stakeholders and define the economic hypothesis and acceptance criteria. Weeks 2 to 4. Build the dollarized backtest and a replay simulation. Weeks 5 to 8. Implement a minimally invasive policy in a controlled segment with full tagging for reconciliation. Weeks 9 to 12. Analyze P&L impact, run sensitivity analysis, and decide scale or rollback. Make the pilot reversible and instrumented from day 1. Risks to watch. Oversimplifying costs into a single metric can hide conditional harms. Teams may resist economic constraints as anti-innovation, and integration with finance systems can be slow. Mitigate by starting small with dollarized backtests, co-designing objectives with product and finance, and planning an integration sprint with automated reconciliation tests. Looking ahead, cost awareness scales from single model decisions to portfolio-level management. Early on, prioritize cost-adjusted thresholds and dollarized backtests. As capabilities mature, invest in richer economic simulation and portfolio optimization. The long-term goal is a capability where every model ships with an economic spec and an owner responsible for margin impact. When should you build full economic models versus simple thresholds? If the decision dominates a sizable P&L line and interactions are complex, invest in a full model. If the decision affects many small transactions where friction costs compound, a transparent threshold with reconciliation often works best. Prioritize governance and reversibility over theoretical optimality.
2 actionable insights to leave you with. 1. Start with a 90-day dollarized pilot before you change any policy at scale. 2. Require economic SLOs on every model moving to production, dollarized lift, downside risk, and a reconciliation delta. Make those requirements part of your release checklist.
Final reflection. If you want AI to be a predictable contributor to margin, you have to treat models as economic instruments, not just technical artifacts. That shift requires new specs, new governance, and a new muscle for reconciliation. But the result is predictable value and fewer surprise losses.
That's the difference between models and value. If you found this episode valuable, subscribe and share it with your network. And let's connect on LinkedIn. I'm Mirko Peters. We'll be back with more conversations on how data science and AI create real business impact. Until next time.
Thanks for listening to datascience.show. If you found value in this episode, subscribe, share it with your network, and join us next time as we explore how data science drives smarter decisions and better business outcomes.